Physics Part 6. Well, the symbol for physical quantity is printed in italic sloping type, whereas its units in Roman upright type. For example, velocity v is italic, but its unit ms power raised to -1 is Roman. Of course, you will not be able to make this distinction in handwriting. Well, at your level and beyond, there is a special convention for labeling columns and data in the tables of the graph axis. The symbol is printed first in the italic separated by a /. The printing term is solidus from the unit in Roman. Then the data is presented in a column or along an axis as pure numbers. This is illustrated in our figure, which shows a table of data and the resulting graphs for the velocity v of a particle at various times t. Well, this is how we find it here. Ts and s power raised to -1. If Ts is 0, the v ms power raised to -1 is 2.5. If Ts is 1.0, u / ms power raised to -1 is 4.0. And if Ts is 2.0, v / ms power raised to -1 is 5.5. We've got the graph for same, the convention of the labeling tables and graphs. If you remember that a physical quantity contains a pure number and a unit, the reason for this style presentation becomes clear. By dividing a physical quantity such as time, a number, a unit, the appropriate unit you are left with is a pure number. It is then algebraically correct for the data in tables and along graph axis and appears as pure numbers. You may also see the examples in which the symbols for the physical quantity is followed by the slash, then by a power of 10, and then for the unit, for example, t / 10's power raised to 2 s. This means that the column of the data has been divided by 100 to save the repeating lots of zeros in the table. If you see a table or graph labeled t / 10 square s, the figures in the table column or along the graph axis, this means that the experimental data was obtained at values of t of hundreds, 200s, and 300s. Try to get out of the habit of heading table columns and graphs in ways such as t in s, ts, or even recording each reading in the table as 1.0s, 2.0s, or 3.0s. The ratio of the mass of the humpback whale to the mass of the mouse is about 10's power raised to 4. That is minute compared to that is minute compared to the ratio of the mass of a galaxy to the mass of the nucleus, 10's power raised to 68. Order of the magnitude of the quantities. It is often useful to be able to estimate the size or the order of the magnitude of a quantity. Strictly speaking, the order of the magnitude is the power of 10 to which the number is raised. The ability to estimate the particular important in a subject like physics, where the quantities have such widely different values. A short distance for an astrophysicist is a light year, about 9.5 into 10's power raised to 15 m, whereas long distance for a nuclear physicist is 6 into 10 power raised to minus 15 m, the approximate diameter of nucleus. Well, our table gives some values of the distance which may be met in our course.